In this video, we're going to look at how Azure manages data encryption. When you encrypt data, you turn it from readable clear text to ciphertext, which cannot be read by unauthorized people or code without the proper key to decrypt it. There are many situations in a web solution where encryption is critical. Data may be intercepted when it's traveling between the client and the server, or what's called data in motion. Therefore, data in motion must be encrypted to avoid unauthorized access. Data at rest, stored in a database on the server, is also potentially vulnerable. Perhaps someone who looks after the physical servers makes a copy of the database in an attempt to steal sensitive data. That's why it's also common to encrypt data at rest, so the data is unreadable if the person who stole it doesn't have access to an encryption key. In this video, we're going to look at how Azure handles the two different types of data encryption. Encryption in motion, to protect data that's traveling along a network from client to server or even between server components. And encryption at rest, meaning that the data is always in an encrypted state when it's stored in the database. First, let's look at how Azure handles encryption in motion. To ensure encryption in motion, you need to configure your resources correctly in Azure. So these are best practices for that configuration. You should configure your Azure resources to force transport level encryption, or HTTPS protocol. This is a standard encryption in motion protocol for the internet and ensures your data is encrypted while in transit. HTTPS relies on a cryptographic protocol called Transport Layer Security, or TLS. You may have heard of a protocol called Secure Sockets Layer, or SSL. SSL has been deprecated and replaced by TLS. You can set the minimum allowable TLS level on your Azure resources, and you should do this to avoid the use of older, less secure TLS versions. You can limit your attack vector for data in motion by using private endpoints wherever possible, rather than public endpoints that are open to the internet. This is applicable for network connection between resources internal to your server-side cloud solution. You can further limit network access in Azure using tools such as Resource-Based Access Control, or RBAC. You should always limit network access to only those identities who need access and no more. You should also be logging and monitoring request details. Azure tools like Azure API Management will help you do this. And you can also use what's called client-side encryption to keep your data secure in transit. With client-side encryption, the client decrypts any data it receives and then encrypts any data it sends, so the data is always encrypted between the client and the server. Next, let's look at Azure's process for encrypting data at rest or in the database. Azure resources such as SQL Database encrypt data at rest by default using a symmetric encryption key. This key is used to encrypt the data when it's written to the database and decrypt it when it's read. This is transparent to the user of the database. In other words, clients don't have to do anything special for this to happen. It's default behavior at the server level. These symmetric keys are stored on the server, either internally by Microsoft or optionally in a key vault that operations can set up for this purpose. All data encryption keys are further secured by a master key called a key encryption key. This encryption at rest behavior is on by default on any Azure storage account and cannot be disabled. As a valid consumer of the data, you won't see this encryption. But if someone were to detach the database at the physical server and then copy it, they would not be able to access the data within it because they wouldn't have access to the key to perform the decryption. Azure Encryption at Rest is an example of server-side encryption. The encryption keys are managed on the server side, and encryption and decryption happen at the database layer. This means that with server-side encryption alone, data would be decrypted and therefore vulnerable in motion or on the network. As mentioned, all Azure storage accounts have server-side encryption enabled by default. Client-side encryption is an option on some Azure storage account types. With client-side encryption, the encryption key is typically stored in a separate secure resource, such as an Azure Key Vault. The encryption and decryption take place on the client side instead of the server side. In this scenario, the client encrypts the data before it's uploaded to the server, so it's stored on the server in an encrypted state by a key managed by the client, usually in a key vault. When the client downloads or reads the data from the server, the decryption is also done at the client. This way, the data is always encrypted while in motion on the network. Azure SQL Database has its own versions of the standard encryption types. Transparent Data Encryption, or TDE, is the Azure SQL Database version of encryption at rest. Your Azure SQL Database resource instance will manage keys for this for you by default, but you can also choose to manage your own keys, called Bring Your Own Key, or BYOK, by storing the key in an Azure Key Vault. Always Encrypted is Azure SQL Database's solution to encryption in motion. The client manages a key, which can be stored in a key vault, in a Windows certificate store, or in a hardware security module. The client uses a SQL client like Microsoft SQL Server Management Studio to issue TSQL commands, which tell the database which columns of data to encrypt in motion. In this video, I'm going to show you how to manage transparent data encryption on a SQL database in Azure. Transparent data encryption keeps your data encrypted at rest, so if anyone steals the data and doesn't have the key to decrypt it, then they can't read it. So I'm in Azure, and the first thing I'm going to do is create some resources. So I'm going to click on Create a Resource, and I'm going to set up my SQL database. So I'm going to type SQL Database, choose SQL Database, and hit Create. So I have my subscription filled in. My resource group is already existing, so I'm going to select it. Under Database Details, I'll give it a database name of SQL 2526. And for server, I need to create a new server, so I'm going to click Create New. And on the blade on the right, I'll give it a server name of Server 2526. Server admin log is my own sysadmin, so I can name it whatever I want. I'll call it bbrooks26, and it needs a password, so I'll give it a password and verify, confirm that password. And location, I have all of my resources in Central Canada. Canada Central, hit OK. So that's set up. I'm going to leave the rest of this as default and hit Review and Create. So now I'm going to hit Create, and it's creating my SQL database. So while that's going on, the next step I'm going to do is I'm going to create a key vault. We need an Azure Key Vault to store our encryption key for this demo. So I'm going to go back home, hit Create a Resource, type in Key Vault, choose Key Vault under New, and hit Create. So I'm under Create Key Vault. I have my subscription set up. I'll choose my resource group, same resource group. My Key Vault name is going to be Vault 2526. Again, I will put it in the same region, and I'll leave the pricing tier as standard. So if I scroll down here under Recovery Options, you need to make sure that Soft Delete is enabled, and you need to enable Purge Protection. So I'll hit Review and Create, and hit Create. So transparent data encryption will not work unless you have Purge Protection turned on and you have Soft Delete. And what that means is that when you delete the key vault, it's going to actually stick around in the background for 90 days before actually deleting. So it just protects your keys. And same with Purge Protection. It protects your keys from being destroyed. So that deployment is complete. It looks like both our deployments are complete. So if I go back to Home and I go to my resource group, I can see my SQL Server and SQL Database. Okay, my key vault hasn't really shown up here, but it will show up here eventually because I know that it's been created. So I'm just going to go into my SQL Server, Server 2526, and on the left, if I scroll down to Security, there's a section called Transparent Data Encryption. So you can set transparent data encryption on your server. And what this will do is it will encrypt all of your databases. And you won't have to do anything as a client. It just works. So here we are in transparent data encryption, and you'll notice that it's already on because by default it's on, and it's using what's called a service managed key. So a service managed key is just a key that the server itself creates and manages for you, and it automatically rolls it over on a regular basis as well. But sometimes you might want to manage your own key, and that's why we set up the key vault. So we're going to manage our own key, our own customer managed key. Now, I'm going to go to my key vault. So I didn't see it in my resource group yet just because of delay, but I'm going to go to my home page, and I can see it here, Vault 2526. So if I click on here, what I'm going to do is create a key that we can use for our transparent data encryption in our server. So on the left of my key vault, I'm going to click Keys under Settings, and at the top I'm going to click Generate/Import. So my option is to generate. I want to generate the key. I need to give it a name, so I'm going to call it TDE-key, and it's enabled, and I'm not going to set any activation or expiration date. So a TDE key cannot have any expiration date, and it has to be enabled. So I'll hit Create. Now if I click on that key, and I click on the current version, I can see that it's all set up. Another thing is it needs the proper permitted operations. So I have them all checked, and it needs unwrap key, wrap key, and it needs encrypt and decrypt. But we'll have them all checked so that it works fine for a TDE key. So if I go back home and I go to my resource group, and I go to Sql Server, my Server 2526 instance, and on the left I scroll down, I want to go back to Security and click Transparent Data Encryption. Now I'm going to set my customer managed key on my transparent data encryption, and that's the key that we just created in the key vault. So I'll click customer managed key, key selection method, select a key. So under select a key, I'll click change key, and now I can choose my key vault under my subscription, Vault 2526. I can choose the key, which is TDE-key, and I need to choose a version. So you can have different versions of the key. We only have one because we just created it. So we'll choose the current version, and I'll hit select. So you can see it says there's a checkbox underneath change key that says make the selected key the default TDE protector. So it's going to automatically make that key my TDE key. So I'll hit save, and that's all there is to it. So I've now set the key, so all of the data that's in my database will be encrypted. Now when I look at it with a client, I will be able to see the data just like I always do. The only difference is that if that key is not in the key vault, then I won't be able to access any of my data because it will be encrypted. And if anybody stole my data, or somebody who is working with the data on the actual physical machine where my database is stored, tried to access the data without having that key, then they wouldn't be able to. You can also rotate keys by coming here and basically just hitting change key and choosing a new key that you've created in the key vault. So in conclusion, transparent data encryption is an easy way to secure your SQL data at rest. SQL Server has a feature called Always Encrypted, which ensures your data is encrypted when in motion between the client and the server. This is a feature on the standalone on-premises version of SQL Server, and it can be applied to a SQL database resource instance in Azure, or a standalone SQL Server instance implemented in a virtual machine on Azure. In this video, we're going to look at the details of how the Always Encrypted feature works. First, there are multiple use cases for this feature. Using the standalone SQL Server, you can use this feature when both the client and the server are on premises, or in other words, not in the cloud. So it can be used in a company intranet, for example, which is run in a single physical data center. Another use case is when the client is on premises, say in that physical data center, and the database is in the cloud, as an Azure SQL database resource instance or a SQL server on a virtual machine. This would be useful if your company wants to take advantage of cloud database flexibility, but is concerned about the safety of the frequent network traffic between the data center and the cloud. And the final use case is when both the client and the server are in the cloud. An example of this would be if you had a cloud solution that used Azure SQL database resource instances as databases for various microservices. There would be a lot of potentially interceptable data flowing between the front end or client and back end or server of your microservices. This would encrypt that data, making it more secure. Let's look at how always-on encryption works. First, the SQL database requires a master key, which is used to encrypt other keys. This is done using a TSQL statement on the database. You can do this using a SQL client, such as Microsoft SQL Server Management Studio. Then a column master key is generated at the table level. This will encrypt the column encryption keys that encrypt the actual column data. These column master keys are never stored in the database. Only their location is stored. They're physically stored in an external key store like Azure Key Vault. You then choose the columns in your tables to encrypt. This generates column encryption keys that do the actual encryption. These in turn are encrypted by the column master keys. From the client side, you can use always encrypted enabled client drivers, such as the Microsoft.data.sql client NuGet package for .NET solutions. These libraries transparently decrypt data that you read and encrypt data that you write to the database. You can use Microsoft SQL Server Management Studio, or Ssms, or also PowerShell script to perform always encrypted features on your database. These features include creating a master key on the database, and each database can only have one master key, creating column master keys, creating column encryption keys, creating encrypted columns on tables, and encrypting existing data in tables. There are two types of encryption to choose from with always encrypted. Deterministic encryption means that a given value will always result in the same encrypted value in a column. For instance, if the column value is the integer value 10, then any integer value 10 will have the same encrypted value. This allows things like grouping and joining by encrypted values. With randomized encryption, equivalent values will not necessarily be encrypted the same way. While randomized encryption is more secure, it also rules out actions such as grouping and joining by encrypted data. Finally, there are specific database permissions used for always encrypted data. Alter any column master key allows creation and updating of column master keys. Alter any column encryption key allows creation and updating of column encryption keys. View any column master key definition allows column master keys to be read under the user, which is necessary for the querying of tables with always encrypted columns. And view any column encryption key definition is the same permission for column encryption keys, also required for querying always encrypted columns. Note that the two view permissions are given to public users by default in SQL Server, but not in Azure SQL Database. So in Azure SQL Database, you'll have to apply those view permissions. Additionally, anyone responsible for managing always encrypted features in your SQL Server or Azure SQL Database instances will have to be assigned the two alter permissions. In this video, I'm going to demonstrate how to enable the always encrypted feature on an Azure SQL database. So if I go into Azure, I'll show you that I already have a SQL database set up. I'll go to my resource group, and you'll see I have a SQL server called Sql Server 2426 and a SQL database called SQL DB 2426. So this is the database we're going to be talking to, and the way we're going to talk to that database is through Microsoft SQL Server Management Studio, or SSMS. So I'm going to connect to my SQL database using SSMS. So at the very top, I'll hit File and hit Connect Object Explorer. So I need a server name. So if I go back to Azure for a moment, and I click on my SQL Server instance, SQL Server 2426, on the overview, there's a server name, SQL Server 2426.database.windows.net. So I'll copy that back to SSMS, and that's what you copy into server name. Authentication is going to be Sql Server Authentication. And for login, I'm going to use my sysadmin login. And hit connect. So now I'm connected. So if I open up databases, and I see my database, SQL DB-20426, and if I open that up, and I open up tables, you see I don't have any tables yet. So I'm going to right-click on SQL DB-20426. I'm going to hit New Query, and I'm going to run the following query. I'm going to create a table called People. There's a People ID, a name, which is a string, and an age, which is an integer. And I'm going to insert some people records. Frank Zappa, Bob Dylan, Lenny Kravitz, Frank Sinatra, Paul McCartney, and Bob Seger. So I'll hit execute. So that's complete. So if I take a look at the records by doing a select star from people, I see all of my data. Now what we're going to do today is we're going to encrypt the age column so that people who are looking at the data this way just by querying it outside an application won't be able to know everybody's age. But applications or code will be able to. So if I go over to my database, SQL DB-2426, I right-click and I choose Tasks and Encrypt Columns. And I'll just hit Next. Now I'm on the step called Column Selection under Always Encrypted. And I'm going to choose the age column. I could choose the other columns as well, but we'll just do age. And so I've selected the age column. I have to choose an encryption type. The encryption types are deterministic or randomized. What that means is deterministic means that the encrypted data will always be the same when you query it. Randomized means that the encrypted data will be randomly encrypted differently every time you read it. That's safer, it's more secure, but it's a little more challenging because you can't do things like joins. Now for this we don't really care. I'm just going to choose deterministic and I'm going to hit next. So here in the master key configuration in the next step, we need to create what's called a master key so that it can be used to encrypt and decrypt. Now it will auto-generate a column master key, and a column master key is always stored outside the database physically. You have a choice either of storing it in the Windows Certificate Store or an external Azure Key Vault. Just for simplicity, we're going to choose Windows Certificate Store. I'm just going to expand this, click Next, and then I'm just going to proceed to finish now. Click Next, and I'll click Finish. So this is going to take a few minutes. I'm just going to pause until it's done. Okay, that's complete, so I'm just going to close that. So now, back in Ssms, I'm going to rerun the query select star from people. I'll hit execute at the top. Now in the results window, you're going to see something different. The age field now has been encrypted, so you can't read the ages. They're just large hexadecimal values. And if we go back to Azure, I'll just show you that in Azure you'll see the same thing. They're shown slightly differently, but it's the same values. If I go into my database, SQL database, and hit Query Editor, and I'll just log in here. And if I do the same query and hit Run, you'll see the ages, I can't read them, they're encrypted. So this means that anybody who's looking at the database, just querying the database, or working with the database, will not be able to see the data. It's encrypted in the database, so it's encrypted at rest. Now what we're going to do is we're going to call this from an application and see if we can read the age column. So here I'm in Visual Studio. I've created a .NET Core console application called Encryption, and you need one library, one NuGet package. So if I right-click on my project and I choose Manage NuGet Packages, and I hit Installed, you'll see Microsoft.data.sql client. So that's the NuGet package that you need to install. So I'll step you through the code here. In my main, lines 11 through 16, I'm setting up a SQL connection string to my database. I need some information here, so we'll get that now. The data source is your server name. So if I go back to Azure and I go to my server, my SQL server, in Overview, there's a server name. I copy that. And going back to my code, That's my data source on line 12. On line 13, I need the initial catalog. That's the name of my database. So if I go back to Azure, I go to my database, SQL database, and I'm going to copy the name. And back to my code, I paste that on line 13 for initial catalog. User ID and password, I'm going to log in again as my sysadmin, bbrooks26, and that will create my connection string. So on line 18, using that SQL connection object from the connection string, on line 19, I'm creating a SQL command object, doing a connection.create command. On line 21, I'm opening that connection. And on line 23 through 28, I'm setting up a SQL parameter. What we're about to do is insert into the people table. And when you have an encrypted field, you have to use parameterization. If I try to just send an age literal in there, it won't work. So lines 23 through 28 set up the SQL parameter called @age, line 24. Line 25 says it's an int32. Line 26 is an input. Line 27, the value I'm giving it is 92, is the value of the age. Line 28, I add that to my command as a parameter. Line 30 is the command text, or the SQL, insert into people, and it's got the people fields, values, and it's people ID 6. The name is George Washington, and I'm using my @age parameter for the age. So what it will do is it will take that number 92, and the NuGet package that we're using will automatically encrypt that before it puts it in the database. In fact, it will encrypt it before it sends it. So it's encrypted on the network, and it's encrypted at rest. And the reason it encrypts is on line 16. When we create the connection string, you'll notice that we set the column encryption setting to enabled. So that's what tells it to perform the encryption. So lines 23 through 31 are going to insert a record into the people table, and it's going to encrypt the age. Then on line 33, we create a select. So we want to select all the records from people. And on lines 35 through to 45, what I'm doing is I'm displaying the results on the screen. Notice I'm not doing anything fancy to decrypt. I'm simply going through each record as I read it. On line 37, I read it. And line 39 through 42, I simply get the ID, name, and age from the reader directly, and I write it to the screen. The NuGet package does the actual decryption. So let's run this. I'm going to hit F5, and here's our result. So notice it shows all of the records. There's Frank Zappa, Bob Dylan, Lenny Kravitz, Frank Sinatra, Paul McCartney, Bob Seger, and George Washington, who we just inserted. And also notice their ages. So their ages are no longer encrypted on the screen. So the application can read the age. Now if we go back to Ssms and we run the select star from people, in the results, the very last line is George Washington. So when we inserted it, it was automatically encrypted by the NuGet package. And when we read all of this from the database, the NuGet package on the application side automatically decrypted it. So in conclusion, always encrypted is a feature that keeps data always encrypted at the database level, both on the network and at rest. Applications can use a .NET library to automatically decrypt the data on read and encrypt it on write. So the application code doesn't have to concern itself with the actual encryption. In this video, I'm going to demonstrate encrypting and decrypting columns in a SQL database table using a symmetric key. So in Azure, I have a SQL server set up. You can see it right here. It's called Server 2526. And I'm going to use Microsoft SQL Server Management Studio. So I'm going to go to my SQL Server, and what I need to connect is I need my server name, which is right on the overview of my server. So server name, I'll copy that. And now I will go to SQL Server Management Studio, or SSMS. And on SSMS at the top, I'll click File, and I'll click Connect Object Explorer. Under server name, this is where I want to put the server name. Now I've already got it there, but that's what I've copied. I just paste it there. Authentication needs to be Sql Server Authentication. Login is my sysadmin login is what I'll be using. So that's bbrooks26. I set it up when I set up that server. And then I'm going to give it my password for my sysadmin. And hit connect. So now I'm connected to my SQL Server, and if I open up databases, I see I have a database called SQL2526. If I go back to Azure, and I go to my home page, I have this SQL database set up, SQL2526, and it's connected to Server 2526. So that's what we're looking at. So what we're going to do is create a table. So I'll right-click on my database, choose New Query, and I'm going to run the following. I have a create table. My table is called people, and each record has a first name, a last name, and I'm creating a column called last name encrypted. We're going to use that to encrypt our last name, and then an age. You'll notice that the last name is an n varchar, and the last name encrypted is a var binary. So encrypted data is going to be in var binary. And it needs to be of a size that it's going to fit what we're encrypting. The last names on here are fairly short, so a var binary 128 will fit. If I were to fill this entire n varchar 128 with characters, it probably wouldn't fit. In fact, it definitely wouldn't fit, but we won't worry about that because everything that we have here will fit. I'm going to insert some people, as you see here. So I'm going to run this entire thing. I'll just hit execute. So now on the left, if I open up my database and I open up tables, I see my people table. And if I right click and choose select top 1000 rows, I can see the results. I have my first name encrypted is all null, and then I have some ages. So let's start with the script that is going to encrypt the last name field. So I'm going to close these queries, and I'll right click on my database and I'll open up a new query. And I'm going to copy all of the script that we're going to need, and we'll run it one piece at a time, and I'll explain what I'm doing. So the first two lines say create master key encryption by password equals, and then I have a password. The reason you need a master key on your database is because it's the key that encrypts all of your other keys. So the symmetric key we're going to create will be encrypted by this master key. So if you don't already have a master key on the database, you can only have one per database. Then you should run this and create a master key. You could have your own password, but that will create the master key. Next, we're going to create a certificate. The certificate is used to create the symmetric key. So I'm calling it people_age_cert, and I'm just giving it a subject so you can tell what it is, people ages. And I'll execute that. Now you can see the certificate on the left. If I open up security under my database, and I open up symmetric keys, sorry, not symmetric keys, if I open up certificates, you'll see my people_age_cert. The next thing we're going to do is create a symmetric key. This is what we're going to use for encryption. It has an algorithm, AES_256. It's called people_age_key. And it's encryption by certificate, and that's the reason we created the people age cert, is because it needs a certificate. So we hit execute. Now if I refresh my security folder on the left under my database, and now when I open symmetric keys, you'll see my people age key. And under certificates, we still have people age cert. So we've created the key that we're going to use in order to encrypt and decrypt. So I'm going to run this line here, open symmetric key, people age key, decryption by certificate, people age cert. So that will allow us to use our symmetric key. So I've run that. Now what I'm going to do is I'm going to update the people table, and I'm going to set the last name encrypted to encrypted versions of what's in last_name. So you see it says set last_name_encrypted equals encrypted by key, that's a function we use, round bracket key_GUID, round bracket people_age_key, end round bracket. and the last name is what we're encrypting. So that will encrypt by that key. If I run that, it says 7 rows affected. Just to take a look at what we've done, if I go over to the table on the left, I right-click on People and choose Select Top 1000 Rows. In the results, you see that last name encrypted now has some encrypted data in it. So this is the last name values encrypted. So going back to our list of queries, the next query I'm going to do is an alter table people drop column last name. So I don't want the unencrypted values, so I'm just going to drop the last name field now that I've encrypted those values in a new column. So I'll hit execute. Now on the left, if I right-click on the people table and choose Select Top 1000 Rows again, so now I have no last name field, it's only last name encrypted and first name and age. So nobody will be able to see the last names unless they can decrypt. And that's what we're going to do in our final select here. So we're going to go select first underscore name, comma, and then this is where we decrypt. And we can only do this because we've already opened the symmetric key for use. So we go convert, round bracket, end varchar, comma, decrypt by key, round bracket, last underscore name underscore encrypted, end round bracket, as last name. So that's going to be the last name field. And then the age, since that's not encrypted, from people. So let's run that. So lo and behold, we have first name and last name and age. And now last name is unencrypted. In this video, I'm going to demonstrate how you can set row security on a SQL table to limit the rows that certain users are allowed to see. I'm going to create a SQL database in Azure, and I'm going to connect to it with Sql Server Management Studio. So I'm on my home page in Azure, and at the top left, I have a button that says Create a Resource. So I'm going to click on that, and I'm going to create my SQL database. So under New, in the search box, I'm going to type SQL Database, and I'm going to choose SQL Database from the list. And on the SQL Database page, I'm going to hit Create. So now I'm in the Create SQL Database page, and on the tab of Basics, it's already chosen a resource group for me because there's only one, but you can choose your resource group. Under Database Details, I'm going to enter a database name. So I'm just going to call this SQL Database 2426 just to make it unique. And I'm going to choose Create New for my server. You can use an existing server or create a new one. So in my server name, I'm just going to call this SQL Server 2426. And I have to give it an admin login. This is my sysadmin name. So I'm going to go with bbrooks26. That's the one I always use for these demos. I'm going to give myself a password that I know. Confirm my password. And under location on new server, I'm going to choose Central Canada. And on new server blade on the right, I'm going to click OK. And for the rest of the Create SQL Database wizard, I'm going to just click Review and Create and leave it as default. And then I will click Create. So I'm just going to pause while that's creating because that might take a few minutes, and then we'll carry on from there. Okay, so that's complete. So now we have our SQL database. Now at the top left of the screen, I'm going to click Home, and then I'm going to click Resource Groups, and I'm going to choose the resource group that I created that in, and it's IT_CLDEMA. So I'll open that up. And there are a few things in here, but I will scroll down to what we just created. And down here at the bottom right of the screen, we have SQL Server 2426. That's the SQL Server that we created the database on. And the database itself is called SQL Database 2426. So what I'm going to do is open the SQL Server, because what we're going to do now is we're going to connect to this using Sql Server Management Studio. So if I just flip over right now, I have Sql Server Management Studio running on my local machine. And at the top of Sql Server Management Studio, I'm going to click File and hit Connect Object Explorer. And what we're going to do is connect to that Azure SQL Server. So the first thing we need on the Connect to Server window is server name. Now I'm just going to flip back to Azure. And in Azure, I'm on my SQL Server instance. And on the overview page, there's a server name. So I'm going to copy that, and I'm going to go back to SQL Server Management Studio, and I paste that in server name on the Connect to Server window. Next, authentication. I need SQL Server Authentication. So I'm going to choose SQL Server Authentication. And if you recall, when we created the SQL Server, I gave it an admin name and a password. So I'm going to use that to log in now. It was bbrooks26, and I'll enter my password and hit connect. And it shows me that I have a firewall limitation, so I can't access the server because of firewall rules. So what I'm going to do is I'm just going to go and change the firewall rules on our SQL Server. So if I go back to SQL Server, and on the left, options of SQL Server, if I scroll down to security, there's an option that's called firewalls and virtual networks. I'm going to click on that. And normally you wouldn't open your firewall right up, but because this is a demo, I'm simply going to allow all IP addresses. So under rule name, I'm going to call this rule all. And the start IP is going to be 0.0.0.0. And end IP is going to be 255.255.255.255. Again, normally you would give a proper IP range for who you want to access through this firewall. But I'm just going to open it right up. I'll click Save. And it says it successfully updated server firewall rules up in the top right. And I get a success bar, so I'm going to click OK on that. So now I'm going to go back to SQL Server Management Studio and hit Connect again. And you see now we're connecting to the SQL Server. So in my Object Explorer on the left, I'm connected to SQL Server. And if I open up databases, I should see the database that I created in Azure, and here it is, SQL Database 2426. So I'm going to create some objects on that database now. I'm going to right-click on the database, choose New Query, and in the query window on the right, I'm going to create a new table and populate it with some data. So here's the SQL for that. First is create table people in the window on the right here, the query. And the records are first underscore name, which is an nvarchar 128, last underscore name, which is an nvarchar 128, so those are both strings, and age, which is an integer. Then I'm inserting several records into that people table with several names and several ages. So let me just execute that. So I'll click Execute on the top bar of SQL Server Management Studio, and that's complete. So now in Object Explorer on the left, if I expand my database and then I expand tables, I can now see my people table. And if I right-click on the people table in Object Explorer and I choose Select Top 1000 Rows, I can see that I can query all of my rows. So I'm going to close that query that just happened, the top 1000, and back to my original query. So what we're going to do now is we're going to create some users, and we're going to set them up so they only have access to certain rows. So the first step is to create the users. So I'm going to replace the query code in the query box to the right with these statements. Create user administrator without login. I'm skipping the login to make this simple, so these can be used without a login. Create user Stephen_Segal without login. So that's a first name and a last name from our table. And I'm doing that on purpose, and we'll see why in a minute. And create user Emily_Blunt. And again, that's a first name and last name from the table without login. So I'll hit execute. So that's completed successfully according to the messages at the bottom. The next thing I'm going to do is I'm going to create a function which is going to serve as a rule to how to filter the rows for these users. So the logic looks like this. Create function, and it's called name_predicate in the query window to the right. It has two parameters. At first_name, which is our first name field, as nvarchar 128 since that's the data type, and at last_name, again, is our nvarchar 128. It returns a table with schema binding. The system's going to use this table to determine how to filter rows. So I'm going to select one as result where either the username, and user underscore name with round brackets is a function that's built in. And what it does is it's equivalent to the name of the user who's calling the query. So that would be one of the users we've set up. And if that username is equal to the first underscore name of the record with an underscore, and then the at last underscore name of the record. So first name underscore last name, which is the format of the names of our users, if you recall, then it will return that row or that record. What that will do is it will return a record if the username matches the first name, last name of the record with an underscore in between. Or if the username is equal to administrator. That's a special case. Administrators will be able to see everything. So this determines if a 1 is returned for a record, it means that that record can be seen. Otherwise, it's going to filter out that record. So I'm going to hit execute at the top of Ssms. And messages at the bottom right says that's complete. The next thing we're going to do, so that creates a function, and I'll just show you where that is. If I go to my Object Explorer, and I go under my database, under Programmability, I open that up, and I open up Functions, and I open up Table Valued Functions, I should see it. And there it is, name underscore predicate. So we're going to use that function when we create the next thing, which is a policy. So the next query is, and I put the query in the query box to the right, create security policy people filter, that's what I'm calling it, add filter predicate dbo.name underscore predicate, so that is our function we just created, and I'm passing it first underscore name and last underscore name, those are the two fields that are the input parameters, on dbo.people, so that's our people table, with state equals on. So that just turns this policy on when it's created. So I'll execute that, hit execute at the top of Ssms, and that's complete according to the messages at the bottom right. So that's the policy that does the actual filtering, and it calls the function for every record in the table and determines whether or not it should show it. If name underscore predicate returns a 1, then the record will be shown, otherwise it won't. So what this allows you to do is write any sort of logic to filter records. Now the next step is to grant some permissions to our users. So in the query window to the right, I'm going to replace the query with grant select on people to administrator, grant select on people to Stephen underscore Segal, and grant select on people to Emily underscore Blunt. Those are our 3 users, and they don't have any permissions yet. So minimally, they need to be able to call a select on the people table for us to continue. So I'm going to execute that. And now I'm going to grant some more permissions in the query window. So I've replaced the query window on the right with grant select on dbo.name underscore predicate to administrator, and the same select on name predicate to Stephen Segal, and the same to Emily Blunt. So what this does is it allows them to select using that policy. So it allows the policy to run. So I'll hit execute at the top. So that's complete. Now these users can select the table, and also that policy will apply, and we granted them the ability to select on that function as well, which is what's required in order for the policy to run. So now let's try a select. So in the query window on the right, I replace it with execute as user equals administrator, select star from people, and then I revert afterwards. So revert just puts it back to the context of myself as the current user. So I set the user, I do the select, and then I set the user back to myself. So I'll execute that. And in the results window at the bottom right, you can see that administrator sees all of the records. So that's good. That's what we want for administrator. Now, if I try my other users, I'm going to enter, instead of administrator, I'm replacing the term administrator in the query with Stephen underscore Segal. And it's case sensitive, so capital S's. Now when I hit execute at the top, it's now run our policy, And it ran our policy last time too with administrator, and as you recall, our logic said that if it's the administrator, any record returns 1. So that's what our function said. So it returns all records. Now, Stephen _ Segal is not the administrator, but the name of the user matches the pattern of the first name Stephen, last name Segal, and the underscore in between. So Stephen Segal only sees his own record. So it's filtered out all the other records for Stephen Segal. Now if I enter Emily _ Blunt as the user in the query, and I hit execute at the top, and you now see that Emily Blunt is the only record that Emily Blunt can see. In this video, I'm going to show you how to manipulate an Apache Spark data frame using Azure Databricks Workspace. So I'm in Azure right now, and I've already got a Databricks instance started, but I'm going to show you how to create your own. So on the home page, I'm going to click Create a Resource at the top left. And on the New page, in the search box, I'm going to type Azure Databricks. And I'm going to choose Azure Databricks and click Create. Now on the Basics tab of Create an Azure Databricks Workspace page, I'm going to choose my resource group. It already exists. And I'm going to choose a workspace name. And that would just be whatever you wanted to create. So it could be Databricks 1, 2, 3, 4. And then a region and pricing tier can be defaulted. And you can click Review and Create. And once it's done validating, you can click Create. Now, as I mentioned, I've already created a Databricks instance, so that's how you'd create your own. Go back to Home. And in the middle of my screen under Recent Resources, I'm going to click Databricks BB. That's my Databricks instance. And on my Databricks instance, on the Overview page, I'm going to click Launch Workspace. So this launches my Azure Databricks Workspace. Now the first thing that you need to get started is a Databricks cluster. So on the options on the left of the page, click on Clusters. I already have a cluster set up called Demo Cluster, but I'll show you how I created that. At the top left, there's a blue button that says Create Cluster. So I'll click that, and you would give it a name, such as I did, Demo-Cluster. For cluster mode, choose Single Node, because this is a very simple example, so you don't need a complex cluster mode. Pool can be None, and the rest can be defaulted. Databricks runtime version can be 7.5. Node type standard DS3v2. And then you would click Create Cluster, which is a blue button on the top main menu. When you do that, it's going to create your cluster and start it up. So if I go back to Clusters on the left-hand menu, when you're on this Clusters window, what you're going to see in the table is on the left, where my demo cluster has a green circle, you would see a spinning icon while it's creating the cluster. And once it's created and running, it will show as a green dot. And it takes a few minutes for a cluster to start up. So now that we have a cluster, I'm going to create a notebook. So I'm going to click Home at the top left, and under Workspace, under My User, I'm going to click the down arrow beside My User under Users, and I'm going to choose Create, and I'm going to choose Notebook. So Create Notebook, I have to give it a name. So this will be Demo-Notebook. We're going to force the language in our code, so I don't need to choose a default language. I'll just let it be Python. And then you have to choose your running cluster. So mine already defaults to Demo-Cluster. Click Create. So now I have Demo-Notebook, and we can start using the notebook. So I'm going to copy some code here and explain it. So I've copied code into the notebook. The first line, line 1, just tells it to run this as Python. So %Python. Line 2, data equals spark.read.csv. So we're reading in a CSV file, or comma-separated value file, which can be created in Excel. The one that we're using actually comes with Databricks Workspace. So it's a demo CSV. called data_geo.csv, and this is the entire path on line 2. The other arguments here, header equals true just tells it that there are headers on the CSV that are the field names. And infer schema equals true tells it to figure out the schema from the CSV. So that will create a data frame. And on line 2, you see we assign it to data, so that will be our data frame. On line 3, I display data. So that displays our data frame as a table. There are some other lines 5 through 7 are currently commented out with the pound sign. So we'll just leave those for a moment and come back to them. Now I'm going to hit Shift Enter in order to run these commands. So it's run the commands, and I now have a table underneath the commands. So this is the result table. You'll see it has several fields. The ones that we're going to focus on today are the city and the state code and the population estimates. So I'm going to run this again, but I'm going to change the code slightly. If I go back to the code, I'm going to comment out line 3 with a pound sign, and I'm going to uncomment lines 5 through 7. So what we're doing here is we're going to read the CSV again on line 2, but then we're going to do some transform. On line 5, we filter the data down to the columns that we want. So we create a new data frame called filtered_data, and that's equal to data.select, and we select the city field, the state code field, and the 2014 population estimate field. Then what we do on line 6 is we take that filtered data and we call a function called create or replace temp view, and we give it a name, data_geo. Now what that does is it loads the data into a temporary table called data_geo. The reason we do that is because in a minute we're going to run a SQL query on this, and you can't run a SQL query directly on a data frame. It has to be a table. So this creates a temp table with the data. On line 7, we're going to display our data frame the same way we displayed the first one, just to see our filtered data. So I'm going to hit Shift Enter and watch that run. So now you see we've transformed our data and we only have 3 columns or 3 fields: city, state code, and 2014 population estimate. Now I mentioned that we're going to run some SQL on this, so let's do that next. If I scroll down, I can go to the next command box, which here is called command 2, and I'm going to enter some SQL. So line 1 is %SQL, which just tells it this is SQL. Line 2 says select state code, comma, 2014 population estimate from data_geo. So these are the 2 fields that we want. If I go back up to the table that we've just displayed previously, I don't care about the city. I only want the state code and the population estimate. Notice the special quotations around the field names. This is not a regular quote, it's a back quote. So keep that in mind. On your keyboard, it's right below the tilde. So I'm going to hit Shift Enter and run that. So you see it returns a table, just like before, only it doesn't have the city in it. Another thing that's nice that we can do here is we can visualize this in different ways. At the bottom of the command box, there is something that looks like a little bar chart. And if I hit the down arrow beside it, I can choose different visualizations. One of them is called Map. So choose Map. And because there's a state code as the first column, and then some values as the second column, it will break it up by a map of the US. And you see that it's showing me populations of the different states by state code. I can also choose a different visualization. If I go back to that option list, I can choose something like bar, and I can see the populations by a bar chart. I'm going to go back to map. Now, one of the nice things you can do with these sort of transforms is if you have sensitive data, perhaps you could filter out the data that you don't want to show. So let's say we only wanted to display data for Texas. Well, we can change this SQL to say select state code 2014 population estimate from data_geo where state code equals, and for a literal I use the regular quote, single quote, and not the back quote, and equals TX, and I'll hit Shift Enter. So now you see we've filtered out all the data for the other states, and the only data we have is for Texas. So in conclusion, Apache Spark can be used to perform many data transformations. One useful application for this might be filtering sensitive data. In this video, I'm going to demonstrate how to dynamically mask data in an Azure SQL database. Then, I'm going to go through some advanced threat protection to help protect your SQL Server. So in Azure here, I already actually have a database set up. I'm on the home page. If I go to my resource group, you'll see that I have a SQL Server instance set up called Sql Server 2426 and a SQL database set up called SQL DB-20426. And the SQL Server automatically creates a storage account, which is this one with a large name. So I'm just going to show you how you would create your own. So if I go to Home, I'm going to click Create a Resource. And in the new window, I'm going to type SQL Database and choose SQL Database and hit Create. Now on the Basics tab of Create SQL Database, you want to choose a resource group. It's already filled mine in. You want to give it a unique database name. And under Server, you probably want to hit Create New. And it will come up with a new server blade. And you just have to give it a unique server name. You need to choose a server admin login. This is your name for your sysadmin. And then choose a sysadmin password and confirm it. And then hit OK. Now under Create SQL Database, you can then hit Review and Create. And it should create your resources for you. Now again, I've already done that, so I'm going to go back to my home page. And I'm going to go to my resource group. Now I'm going to open up my database, SQL DB-2426. And in the options on the left, I'm going to go down to Security. And under Security, there's an option called Dynamic Data Masking. So I'm going to open that up. This is what we'll be using today to implement our masking. Another tool I'm going to be using is Microsoft SQL Server Management Studio, also called Ssms. So in Ssms, I'm going to go up in the main menu to File, and I'm going to hit Connect Object Explorer. And in the Connect to Server window, I need to fill in details of my Azure database to connect to it. So the server name, if I go back to Azure for a moment, and I go to my resource group, and I go to SQL Server, on the overview page, there's a server name. So that's what you want. And you copy that. And I'm just going to go back to Ssms and you paste that for server name. For the authentication type, it will be SQL Server Authentication. And for login, I'm going to use the sysadmin user that I set up when I created the database. Mine happens to be bbrooks26 and the password that I set. I'll hit connect. So now I'm connected remotely to my database. So under Object Explorer, I can open up Databases, and I can see my database, SQL DB-2426. So what I'm going to do now is I'm going to set up a new user. Because bbrooks26 is my sysadmin user, I also want a user that's not an administrator. And you'll see why in a little bit. So the first thing I'm going to do is I'm going to create a login. So I'm going to right-click under Object Explorer on my server and hit New Query. And my new query will be create login tester with password equals, and I have a valid password. So I'll hit execute. So that's complete. Now in the Object Explorer on the left, if I open up security and logins, I see my login tester. Now I'm going to create a user that uses that login. I need to create him twice. Once on the system database and once on my Sql DB-20426 database. So in Object Explorer on the left, I'm going to open up System Databases. I'm going to open up Master. I'm going to open up Security, and I'm going to create a new user. So I'm going to open up Users. Now you see that my tester is not there yet. I'm going to right-click on Master, hit New Query, and I'm going to run the following query. Create user tester for login tester. That's complete. Now I'm going to right-click on Sql DB-2426 in the Object Explorer and hit New Query. And I'm going to run the same create user tester for login tester statement. And I'm also going to run sp add role member. So my tester is going to be a db_data reader. And I'll hit execute. And that's complete. So the only permissions that this user has is to actually read, and they're not an administrator. And now what I'm going to do is I'm going to go back up to File at the top of Ssms, click and hit Disconnect Object Explorer, then File again and hit Connect Object Explorer. And now instead of logging in as bbrooks26, I'm going to log in as my new user tester. So log in as tester. I will give the password that I created the tester user with, hit connect. So now I'm logged in as tester. So all the queries I do will be from the tester user. So I've logged in just to see that this actually works. Now I'm going to log out by hitting File at the top, Disconnect Object Explorer, File again, Connect Object Explorer, and I'm going to log in again as bbrooks26. Now in Object Explorer, I'm going to open Databases, and I'm going to right-click on Sql DB-2426 and hit New Query. And what I'm going to do now is I'm going to create a table called People. So here's the query, create table people. It has a people ID, which is a primary key, name, which is a string, and age, which is an integer. And I'm inserting some people: Frank Zappa, Bob Dylan, Madonna, Frank Sinatra, Paul McCartney, and Bob Seger. So I'll hit execute on that. That's complete. So now in my query, if I go select star from people and hit execute, I can see all the information in my table. So let's go back to Azure for a moment. Now what we're going to do is we're going to create a mask on that table. Now what a mask does is it simply hides data in the columns. So I'll go back to my resource group and I'll go to my SQL database instance. And on the options on the left, I'm going to scroll down to Security, and I'm going to click Dynamic Data Masking. And I'm going to hit Add Mask at the top. Now select what to mask. I already have people under the table because it's already chosen that. Column, I'm going to choose name. So I'm going to mask the name column. Under Select How to Mask, there's several options for masking field format. Default value will replace strings with an XXXX. It will replace numbers with a 0, and it will replace dates with a 01011900. You can also do credit card value, and it'll make it look like a credit card value. And email, it'll make it look like an email. And then the last one is grayed out, but it's random number range. And that only works with numerics. So it will put random numbers in place of numerical values. So we'll choose default value, and I'll hit add. And then when I'm back at the dynamic data masking window, I'll hit save. And that's successful, so I hit OK. So now let's go back to Ssms. And I'm going to run my query again, select star from people. I'll hit execute. Now the first thing you should notice in the results is I can still see the names. So those are supposed to be masked. The reason I'm seeing them is because I'm an administrator. Administrators can always see the data. Masks do not work on administrators. That is why we created the tester user. So I'm going to close this query, and with Object Explorer highlighted, I'll go up to File, hit Disconnect Object Explorer, go to File again, Connect Object Explorer, and log in as tester. Okay, so now I am the tester user. So I open up Databases. I'll right-click on Sql DB-2426, hit New Query, and once again I'll try select star from people. Hit execute. So now in the results, you see that I can no longer see the names because they're masked. So name is now XXXX. Now, as I've mentioned, this will mask for all non-administrator users. Another thing you can do is you can turn off masking for particular users. So if I go back to Azure under Dynamic Data Masking, there's a section here that says SQL users excluded from masking. I can put a semicolon limited list of users here. So if I entered tester and hit save, and that's successful, so I hit OK. Now, if I go back to Ssms and I execute my query again, I can now see the names because I've turned off masking for my particular user. Now, the next thing I'm going to show you in Azure is advanced threat protection. So if we go back to Azure for a minute, so I'm just going to back up to my resource group, and I'm going to go into my SQL database, and on the left in the options, I'm going to go down to security and click on Security Center. And it takes me far to the right. I'm just going to scroll back over. The Security Center window has Azure Defender for SQL enabled at the server level. By default, it should be enabled. And I'll click Configure. And I just want to show you some advanced threat protection options that are available. On the server settings, if I scroll down here, there's a section called Advanced Threat Protection Settings. And what you can do is you can set alert emails. So you can set a semicolon separated list of emails of who you want alerts sent to. And you see it also has checked also send email notification to admins and subscription owners. So it'll send alerts about any sort of attacks that it recognizes. And if I click on advanced threat protection types, you'll see some of the stuff it checks for. We're checking for all of them, but there's SQL injection vulnerability, data exfiltration, unsafe actions, any brute force attacks, and anomalous client logins. So by turning this on, you can protect your server. So in conclusion, you can use dynamic data masking to hide column data from non-administrator users in Azure SQL database. Beyond masking data for security reasons, I've also briefly just shown you advanced threat protection options that you can use to keep your SQL Server instance safe from common cyber attacks. There are cases in which business-critical blob data needs to be immutable, meaning once it's been written, it cannot be overwritten or deleted for a given period of time. This type of immutability is sometimes referred to as write once, read many, or WORM for short. As the name suggests, you can only write the data once. After that, you can read it as much as you want, but you can't change it or delete it for the immutable period. Immutable blob storage is useful for any case where history of the blobs needs to be maintained for a period of time. In Azure, immutable blob storage is available for blob storage, block blob storage, general purpose v1, and general purpose v2 storage accounts. In this video, we're going to look at how Azure implements immutable blob storage. Some common use cases for immutable blobs are legal investigations. In the case where blob data becomes relevant to a legal case, say for example, sensitive data is stored in blob storage that may show illegal behavior relevant to a court case, then a legal team can demand an immutable period be set on that blob storage to guarantee that evidence is not modified. It may be for file integrity requirements as well. For example, maybe there's a reporting requirement that report information remain unchanged for 6 months after initially being reported to support historical report viewing. And it may help meet regulatory compliance rules. For example, it may be information pertaining to income tax, and the government requires the data to be retained unchanged for a set amount of time. Here are some common features of immutable blob storage. All data tiers are supported. These tiers are hot, warm, and archive data. You configure immutable blob storage policies at the container level. which means that all data within the container is affected by the policy. You can organize your blobs by container to facilitate these policies. There's a time-based policy, which relies on a configurable retention interval that starts from the blob's creation. So if your requirement is to make blobs immutable for a month after they're created, you can do that. There are also legal hold policies, where the policy time span is dependent on tags being assigned to the container. While an immutable blob storage policy is in effect, a policy audit log is kept that identifies the user and what command they performed. This is maintained for the length of the policy. Now let's look at how Azure implements write once, read many, or worm logic. The multi-write aspect of the worm rules applies to all containers that have immutable blob policies applied, whether or not the policies are in their effective retention periods. Basically, any applied policy prevents explicitly writing over existing blob data. If the policy is within its retention period, then in addition to being non-writable, the blob is also non-deletable. In this state, container deletion will also be denied, as will storage account deletion. However, if policies exist, but no policies are within their retention period, then the blobs can be deleted. Now let's look closer at time-based retention policies. They have an effective retention period. As briefly mentioned, this is the time from the blob's creation to the blob's creation plus the configured retention period. Operations can reconfigure this period, which doesn't affect existing blobs, but new blobs calculate their effective retention period using the latest retention interval. And there's a special configuration you can enable called Protected Append Blob Writes. This allows new data to be appended to an append blob. Now normally this would seem like a violation of the worm policy, because appending to an append blob is multiple writes to the blob. But this allows only appending data, which doesn't affect previous data. The worm policy still applies to previous appends to the append blob. In other words, you can't perform multiple writes to previous appended data. You can only append new data if this configuration is enabled. Legal hold retention policies work differently. They're not time period based, they're tag based. These blobs are in their effective retention period when they're tagged. They're immutable until the legal hold is lifted by removing the tags. You can combine legal hold retention policies with time-based retention policies, and blobs will be immutable as long as at least one policy associated with them is in its effective retention period. So in this course, we've examined how to utilize tools to secure data in Azure Blob Storage and SQL databases. We did this by exploring encrypting data across a platform, database encryption and managing transparent data encryption, enabling always encrypted and encrypting single columns in Azure SQL Database, applying row-level security with group membership, using data frames in Databricks, configuring advanced threat protection and dynamic data masking, and using immutable storage on Azure Blob Storage. In our next course, we'll move on to describe the features and securing data for the Azure Data Lake Storage Gen 2, securing data at rest, processing big data, and monitoring the Azure Blob Storage service.